Okay, so section 5.5 is on systems of inequalities. So you should have graphed systems of linear inequalities before. I know y'all do that in Algebra 1, possibly Algebra 2. But we're going to graph other things as well. So just some things to keep in mind. The solution of an inequality is any ordered pair that gives us a true statement. Remember, inequalities are the ones where you've got to graph the line, either dotted or solid, and shade one way or the other, because you have an infinite number of solutions that fall under the line or over the line. If it's a system, then it's where their shading overlaps. So an ordered pair solution for an inequality is said to satisfy the inequality. For it to be a solution to a system, it's got to satisfy both. And when you shade, you're shading a half plane, like half of the xy coordinate plane. That's only if it's a line. A solid line is used to show that the line is part of the solution set, and a dashed line is to show that it's not part. So a solid line is going to go with an equal to, and a dashed line goes when there's not an equal to. All right, so we're not going to worry with that. Okay, so just basic, can you graph an inequality, a linear inequality? So let's start with the easy one. Let's start with this one that is already in the right form. So this has like an understood plus 0. So we're going to start with a y-intercept of 0. Our slope is down 3, right 4, which means I could go up 3 and left 4. Because there's an equal to, I'm going to draw a solid line. And it's greater than, so I shade above the line. It's easier to think shade above below than it is to pick a test point, but if you wanted to pick a test point, you could pick the point like 1, 1. So this is 1 and this is 1. It's saying 1 is greater than or equal to negative 3/4, which is a true statement. So you shade that side of the line. All right, so for this one, we've learned the 2 ways to graph this. You can make a table, like a 0, 0 chart, and graph the x and y intercept, or you can get y by itself. I prefer to graph an x and y intercept because I think that's a little faster. So if I make my little 0, 0 chart, if x isn't there, then we get y is negative 4. If y isn't there, we get that x is 2. So we have a point at 2, 0 and a point at 0, negative 4. If you want to get y by itself, you have negative 4 as your y-intercept, and you go up 2 over 1, which would give you the same points that I have. Trying to get some more points, but I think I went too high with that one. So up 2 over 1, up 2 over 1. All right, let's see if I can draw a straight line. This is also a solid line because there's an equal to. It's not a straight line because I can't draw a straight line. All right, and it says greater than. Oh, see, my plan backfired. I forgot. It's easier if you have y equals if you're going to try to shade with my method. Teaches me to act before I think, right? All right, so divide through by negative 2, which is going to flip this symbol. All right, so you see I have my negative 4, then up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. All right, but as long as you have it in y equals form, then you can use this says less than, so I'll shade less than. All right, again, if you pick a test point, you could do 0, 0. And then this would be 0 minus 0 is greater than equal to 8. 0 is greater than 8. That's false. So you shade the other side. So 0, 0 is here. It doesn't work. So you got to shade the other side of the line. Again, I just like to think less than, below, greater than, above. All right. So for these, we have to remember the whole like a buck square thing that we discussed in chapter 2, or you just remember what you got. This is saying y values are less than 1. Well, 1 on the y-axis is here. If I do a bunch of points where the y value is 1, then I would get this line right here. There's no equal to, so we're going to say this is a dotted line. because the line is not a part of the solution. We just get up to the line. And we want anything that's greater than that, so we want the stuff above it. Now when you shade, you should probably color and not scribble, but it's really hard to color on this board, so I just scribbled. Alright, so here we have x is -2. So here's -2 on the x. You got a bunch of points that have that same x value. So we're going to end up with a solid line this time because there's an equal to. So the points on this line do work. And it says less than, so we want things to the smaller side, so the more negative numbers. Alright. I'm tired of writing with purple, let's switch to it. Okay, so if I want to graph this, so here's the thing. We skip section 2.8 because I want to do circles when I do the rest of the conic sections. But you have to be able to graph a circle here. I want you to understand we're going to keep them really, really simple. If you have x squared plus y squared equals a number, that means you have a circle who is centered at 0, 0 and has a radius of 4. Okay? Because that's the square root of 16. Alright. Sometimes we'll get circles that look like this, but you're not going to get them in this lesson. If I gave you this, then this circle would be centered at 1, -2 and have a radius of 5. These numbers give you the center, opposite of what they say, and then the square root of that number is going to be a radius. So again, I'm not going to make you do anything too crazy with circles until chapter 7, but you have to be able to graph a basic circle. Alright, so this one we have a center at 0, 0. From there, we're going to go out 4, and again, we keep it simple. Just go out 4 in the main 4 directions. And we're going to draw a circle. This one has an equal to, so we're going to draw a solid circle. And we're going to pretend that it actually looks like a circle, and not something weird. Alright, so with circles, greater than is outside, less than is inside. If I took the point, say, 2, 3. That's square root 2, that's 4. If I square 3, that's 9. 9 plus 4 is 13, which is not greater than 16. So the points in here are not good. If you take a point out here, then it will satisfy that inequality. So all of the points outside the circle are good. So again, I do a lot of scribbling, but you're coloring everything outside of the circle, because all of the points outside of the circle and on the circle, because it's a solid line and equal to, are solutions to that inequality. Alright, so we have a system of inequalities. We're going to put two of them together. The solution is where your shading overlaps. So, for this top one, so for this inequality, first of all, I'm going to move x to the other side. Divide everybody by -3. So since I divide by a negative, my inequality symbol flips. This is going to be 1/3 x minus 2. So start at -2, up 1, right 3. This does not have an equal to, so it's going to be a dotted line. So points on this line are not part of the solution set. It is greater than, ultimately, when we get here, it's greater than, so we're going to shade above. So it's everything up here. Alright, for the bottom one, move the 2x to the other side. Divide through by the 3. You divide it by positive, so this guy stays. You have a y-intercept of -2, and your slope is down to right 3. And we have a solid line, so points on this line that border the shaded region are solutions. And it says greater than, so we shade up here. So your solution set is where those overlap. So red and blue make purple. We will highlight in purple where our solutions are. So all of this area in here. All right. So you see that I changed this because I wanted you to see some other things, because they may have you graphing anything that we've graphed up to this point and a circle. All right, so if I'm going to graph, hold on, I'm going to graph the top one. That is a quadratic. You have to remember a little bit about what quadratics look like in your transformations, or be able to type it in your calculator and look at it, or make a table or something. But this is going to be a quadratic. We started at -4, and we're like up 1 over 1, out 2, up 4, in both directions, and that gives us a decent quadratic. All right, this is an equal to, so it's a solid parabola. Greater than for a parabola. So if you take a line, greater than is above. Well, if I take my line and I curve it up, then I'm squishing that stuff to the inside. Okay, so for a quadratic, it depends on which way it's facing, so you got to think about it. If this were a flat line, I'm shading greater than, so up here, but since I'm curving those lines in, that greater than gets stuck in the middle. If it was less than, it'd be everything on the outside. All right, so that's the quadratic. Again, if you want to pick a test point, you can do that. If you pick 0, 0 for this, and you try to plug it in up here, you get 0 is greater than or equal to 0 minus 4. So 0 is greater than or equal to -4, which is a true statement. So you know you shade inside with the 0, 0. All right, for the log, we just did those on the test we took the other day. So remember, we write these in exponential form and make a table with -1, 0, 1 for the y. So we get 1/2, 1 and 2 for the x. 2 to the 1, 2 to the -1 is 1/2. 2 to the first, 2 to the 0 is 1. 2 to the first is 2. All right, so if I plot those points, we have a point at 1/2, -1. We have a point at 1, 0, and we have a point at 2, 1. And remember that logs kind of flatten out this way and turn and go up straight down this way. All right, but bad news. That was supposed to be dotted, so let's see if I can fix it. Because there's no equal to, I should have a dotted graph because the points on that curve are not solutions. All right, so again, less than. If you have this straight, less than would be down. All we're doing is scooping it over this way. So our solutions are here. All right, again, if you pick a test point, you can pick 0, 0. If I do log base 2 of 0 in my calculator, is that going to be greater than 0? Well, you can't take log of 0, right? Because the guts of a log have to be a positive number. So you know that can't happen. So 0, 0 is not in its solution set. So it's got to be the other side. Okay, so we are looking for where they overlap, which is going to be this little part right here. All right, and again, the border of this little shaded region that is our solutions, this dotted part, those are not solutions, but this one that's solid, those are solutions, as well as everything in that green area. All right, so the only thing you should really have a whole lot of trouble graphing is going to be the circles. So if you need help graphing a circle, let me know. If you need help with anything, let me know. But graphing circles is something that I anticipate you may have questions about. So please let me know if you have questions. Your assignment will be on the notes and on Google Classroom.